Hi guys, welcome back to Technowizard. So let's start with today's session. So let's see our first question. So this is our first question. In the given figure, the potential difference between the points P and Q is. So in this question, basically we have to find out the potential difference between the points P and Q. Suppose the voltage at the point P is V1 and the voltage at the point Q is V2, right? So we have to find out the potential difference between the two points. So let us first see this voltage source, right? So whenever there is a voltage source, right? So suppose this is VA and this is VB, and suppose this voltage source has a value of 10 volt, right? So always we represent this voltage source as high potential minus low potential is equal to voltage source value, right? So at the high potential terminal, it means this plus terminal, at this terminal VA is connected, it means VA minus, at the low potential VB is connected, so VA minus VB is 10 volt, right? So do remember this. So similarly here the high potential terminal is this and the low potential terminal is this. So suppose the voltage at the low potential is 0 volt, right? So this terminal which is high potential, this must be 10 volt, right, in order to satisfy this, right? So here the high potential is, suppose I'm considering VA and the voltage at B I have assumed 0, which is given 10. It means voltage at A is 10. So here this is 10 volt. Now I'm gonna apply the nodal at the points P and Q. So let's apply nodal at the point P. So we have to consider the currents in the outgoing direction. So current in, I have marked the current in the outgoing direction, right? So let's apply the nodal. So this is already current is given, so it is in the same direction, so it will be plus 2. Next is V1 minus it minus 10 by 2 plus V1 minus, this is 0 volt potential, 0 by 8 is equal to 0. So after taking LCM it will be, so after taking LCM it will be 16 plus 4V1 minus 40 plus V1 is equal to 0. So this is coming as, so this is coming as, okay, 5. So this is coming as 5V1 is equal to 24. So V1 is coming as 24 by 5, which is equal to 4.8 volt. Similarly we will apply the nodal at Q node, right? So here this will be minus 2, because, so first of all mark the current in the outward direction, so the current will be like this at the node Q. So this will be minus 2 because it is in the opposite direction, then it will be V2 minus 10 by 4 plus V2 by 6, right? So let's write this equation. So it will be minus 2 plus V2 minus 10 by 4 plus V2 by 6 is equal to 0. So after taking LCM 12, it will be minus 24 plus 3V2 minus 30 plus 2V2 is equal to 0. So it will be 5V2 is equal to 54. So V2 value is coming as 54 by 5, so which is equal to 10.8 volt. V2 value. Now we have to calculate the potential difference between the points P and Q, which will be equal to, so potential difference will be equal to V1 minus V2. So we have already calculated the value of V1 as 4.8 minus 10.8, so that will be equal to minus 6 volt, right? So for this question, option C is correct, right? So let's see next question. Okay, so this is our next question. The value of V in the circuit shown in the given figure. So in this figure or the circuit, we have to calculate the value of V, which is the voltage across 1 ohm. So here simply we can apply the nodal. So let us assume the voltage at this node is V1 and this is our reference node, which is grounded. So now we will apply the nodal. First mark the current in the outward direction, right? So this will be simply minus 3 plus V1 by 1 plus V1 plus 3 by 1 is equal to 0 plus 3, because this nodal current and because this voltage source will support this nodal current, because this voltage source will also supply the current in this direction, so it is supporting this nodal current, that's why it will be plus 3. So this will be 2v1 plus 0 is equal to 0. So v1 value is coming as 0 volt, right? So now this v1 is 0, it means this will be plus and minus 0 volt. Now let's apply the KVL in this loop, right? So it will be, let's start from here, so it will be minus 0, this is minus 3, so this will be plus minus, right? So it will be minus 0 minus 3 and then plus V is equal to 0. So the value of V is coming as 3 volt, right? So option C is correct. So next question is, what is the current through the 2 ohm resistance for the circuit as shown below? Okay, so we have to calculate the current through the 2 ohm resistance. So here this is voltage controlled voltage source, so we can simply apply the KVL in this loop, right? So we'll start from here, so it will be simply minus 6V, right? Then plus V plus 20 is equal to 0, so it will be minus 5V plus 20 is equal to 0. So 5V is equal to 20, so V value is coming as 4 volt. Now we have to calculate the current through 2 ohm, which will be equal to V by R. So the value of V we have already calculated, which is 4. The value of resistance is 2, so it is coming as 2 ampere. So the current through 2 ohm is 2 ampere. So let's see next question. If a resistance R of 1 ohm is connected across the terminal AB as shown in the given figure, then the current flowing through the resistor R will be, okay, so if the value of resistance R is 1 ohm, then we have to calculate the amount of current flowing through this resistor R. So basically this circuit can be solved using Thevenin theorem, right? So in the Thevenin theorem, we can reduce any circuit or a network in a simple voltage source which is connected in series with a resistance. So any complex network can be reduced into this simple circuit by using the Thevenin theorem. So this is VTH, this is RTH, right? So how you can find out the value of VTH? So in order to find the value of VTH, first of all you have to remove the load across which you have to find out the voltage. So VTH is nothing but it's open circuit terminal voltage, right? Then you have to find out the value of RTH. So in order to calculate the value of RTH, you have to remove the load resistance, then you have to deactivate the circuit. It means you have to replace all the independent sources by their internal resistance. as a- as current source has infinite resistance, so current source will be replaced by open circuit, and voltage source has zero resistance, so it will be replaced by short circuit, right? So I will write here, in order to find out the RTH, you have to replace voltage source by short circuit, and you have to replace current source by open circuit, because current source internal resistance is infinite and voltage source internal resistance is 0, right? So let's draw the Thevenin equivalent circuit of this circuit, right? So first of all, we have to find out. So suppose the voltage at this node is 0 volt, so I'm considering this voltage source. So suppose here voltage is 0 volt, so high potential will be 1 volt. So this is our voltage source, right? So I've already told you high potential minus low potential is equal to the value of voltage source. So I've assumed the voltage at low potential is 0, so the high potential value is coming as 1 volt. So this is 1 volt, this is 0 volt, right? So here suppose the voltage is V1 and the voltage at this node is V2. So first of all, we'll find the value of VTH. For that, we have to draw the circuit like this. So here a current source is present and this is a resistance. So there is another resistance here, a voltage source is present, so this is plus, this is minus, and this is a resistance. So basically this was the terminal. So first of all, we have to open this resistance. So this is 1 volt, so this is 1 ampere, 111, okay? So everything is 1 ohm, 1 ohm, 1 ohm, 1 ohm, and this is 1 ampere current source. So I have open circuited the load, right? So this terminal will be plus and minus, so this is VTH, so I have to calculate this VTH value. So I have assumed the voltage at this node is V1 and the voltage at this node is V2. So let's apply the nodal at V1, right? So first of all, mark the current in the outward direction. So this is 1 volt and this is 0 volt, I mean grounded. So first of all, mark the current in the outward direction. So the current will be like this. So this will be simply minus 1 plus V1 by 1 plus V1 minus 1 by 1 is equal to 0. So from here it will be 2v1 minus 2 is equal to 0. So v1 value is coming as 1 volt. Now next apply nodal at the rate v2. So here the mark the current in the outward direction like this. So it will be v2 minus 1 by 1 plus v2 by 1 is equal to 0. So it will be 2v2 minus 1 is equal to 0. So v2 value is coming as 1 by 2, which is 0.5 volt. Now here this VTH is, so VTH is equal to high potential is connected with V1 minus low potential is V2. So V1 minus V2 is 1 minus 0.5 is coming as 0.5 volt. Now we have to calculate R. So now we have calculated the value of VTH. So in order to find the value of RTH, so first of all we have to deactivate the circuit, right? So this current source will be open circuited and the voltage source will be short circuited and load will be open. So now our circuit will be reduced to after open opening the current source. So this will be 1, right? So voltage source is short circuited, so I have open circuited the current source, and this is 1 ohm, this is 1 ohm, so this is 1 ohm, 1 ohm, 1 ohm, and 1 ohm, and we have open the terminals of the load. So from here we have to calculate the value of RTH. So suppose this is terminal A and this is terminal B, so this terminal will be A and this terminal will be B. Suppose this terminal is C, so this terminal will also be C because there is no voltage drop. So in between A and C, two resistances are connected. In between A and C, these two are connected. It means these two are in parallel, right? So these two are in parallel. It means one in parallel with one will be zero point 0.5. Similarly, this 1 ohm and 1 ohm, they are connected between B and C. It means they both are in parallel, so their overall combination will give us 0 0.5, right? So this will give 0.5 ohm. Similarly, this will give 0.5 ohm. So now overall they both will be in series. So from here RTH value is coming as 1 ohm, right? So I will draw the circuit as, so now we have find out the value of VTH, and the value of RTH is equal to 1 ohm. So value of RTH is 1 ohm and the value of VTH we have calculated as 0 0.5 volt. Now at this terminal we will connect the resistance R, which was equal to 1 ohm, through which we have to find out the current I. So simply we can find the value of current I as VTH upon RTH plus R. So VTH value is 0.5 divided by RTH is 1 plus 1. So this will be 0 0.5 by 2. So current I value is coming as 0 0.25 ampere. So see the option. So option C is correct. So let's see next question. Okay, so this is our next question. The power dissipated in the 1 ohm resistor is 1 watt due to 5 volt voltage source alone and 576 watt due to 30 ampere current source alone. The total power absorbed in the same resistor due to both the sources is, so basically this is a question of superposition theorem, right? So the formula to calculate the total power consumed due to both the sources is given by, so total power consumed is equal, given by plus minus root P1 plus minus root P2 plus so on plus root Pn whole square, where P1, P2, so on Pn are the power consumed in the same resistor due to different sources. Here P1, P2 is given, so we'll simply put the values. So it will be plus minus 1 plus minus, it will be 576, so its whole square. So square root of 1 is 1 plus square root of 576 is 24 whole square. So it will be simply 25 whole square, which will be equal to 625 watt. So total power consumed in this resistor is 625 watt due to both the sources, right? So next question is, the mesh current method works with both the planar and non-planar circuit, uses the Kirchhoff law. So basically mesh current method is only applicable for the planar network. It's not applicable for the non-planar circuits, because Planar circuits are those circuits which can be drawn on a plane, right? So for example, I'm considering this simple circuit, right? So suppose I have drawn a circuit like this, and I have drawn like this. So this is a planar circuit because I can, because there is no overlapping of branches, right? So it is a simple circuit. So this is planar circuit because there is no overlapping of branches. But if there is overlapping of branches and we can't simplify in a planar network, then that network will be considered as non-planar, and non-planar circuits are solved by nodal, right? So for solving the non-planar circuits we use nodal. Mesh is only applicable with the planar, right? And also second statement is it uses Kirchhoff voltage law, definitely. So when we apply the mesh we uses the Kirchhoff voltage law. So second statement is right, first statement is wrong, so option B is correct, right? So let's see next question. Okay, so next question is when the KCL is applied at the super node in the above circuit, the current equations in term of the node voltage V1 and V2 is okay. So basically this is a super node circuit because in between the two node a voltage source is connected. So that such type of circuits are called as super node. So the procedure to solve the supernode circuit is, so you have to apply the nodal leaving the branches connected between the two nodes, right? So when you will apply the nodal you have to leave the branches which are connected between the node 1 and node 2 because it is forming a super node. We can't apply here nodal because no resistance is given, right? So let's write the nodal equation, right? So we have to write the nodal equation as it is. So first of all mark the current in the outward direction at both the nodes, right? So I have marked the currents in the outward direction. So this will be simply minus 4 plus it will be V1 by 2. Now leave these two branches, jump to this node, right? So it will be V2 by 4 and plus 10 is equal to 0. So it will be simply V1 by 2 plus V2 by 4 plus 6. So it will be minus 6, right? So this is equation 1. Now second equation you will obtain using this voltage source. So high potential minus low potential is equal to source value, right? So here the high potential is connected to the second node, it means V2, and low potential is connected to the node 1, so it is V1, and the source value is given as 10 volt. So this is second equation. So in the question it is asking which equation will be the node equation, so it is matching with option A, so option A is correct. So next question is, okay, so this is next question. If VA minus VB is 6 volt, then we have to calculate VC minus VD, okay? So it means VA minus VB, it means high potential minus low potential is 6 volt, and we know that current always flow from high potential to low potential. It means the direction of current in the 2 ohm resistor is like this. So we can calculate the value of current flowing the 2 ohm resistance, which will be simply VA minus VB by 2. So it will be 6 by 2, so 3 ampere current is flowing like this because VA terminal is high potential and this is low potential, right? So we know that suppose this is network B, so this is network B and this is network, and this is network A. If 3 ampere current is entering this network, then the 3 ampere current must come out in order to satisfy the KCL, because charge can neither be created nor be destroyed. So if the 3 ampere current is entering this network B, so obviously 3 ampere will come out from here. So it means from here 3 ampere current is coming out, and from here 2 ampere current is coming, and from here 3 ampere current is coming. It means 5 ampere current will go in 1 ohm resistance, so it will be 5 ampere, right? So I will draw here. So this is 1 ohm resistance, and from here 2 ampere current source is coming, right? So this is 2 ampere source, and this is 1 ohm from here, which is network, it is network B. So from the here 3 ampere current is coming out, so in this 1 ohm 5 ampere current will flow, right? So current is entering, so this terminal will be positive, this will be negative, so the drop will occur like this. So voltage drop across the 1 ohm resistance will be 5 volt, right? So in the question it is asking as we have to find out VC minus VD, right? So VC minus VD is minus 5 volt. So VC minus VD is minus 5 volt, because in VC minus VD this terminal should be high potential and this should be low potential, but in the volt, in the 1 ohm, this is positive, so this is negative, so it is opposite. So correct option is A. So next question is, while Theveninizing a circuit between the two terminals, VTH is equal to short circuit terminal voltage. If we will short circuit, so the voltage across the short circuit is 0. So this option is wrong. So VTH is nothing but open circuit terminal voltage. So option A is correct, right? So we basically remove or open circuit the load resistance. So VTH is nothing but open circuit terminal voltage. So next question is, while determining the RTH of a circuit, voltage and the current source should be left as they are. All the sources should be replaced by their source resistance. All the independent current and the voltage source are short circuited. So option B is correct. So when we have to calculate RTH, the independent voltage source independent voltage source is replaced by short circuit, independent current source is replaced by open circuit, and dependent source remain as they are. We don't remove dependent sources, so they remain as they are, right? So for this question option B is correct. So next question is, Thevenin equivalent circuit to the left of the terminal A and B in the circuit has equivalent voltage source VTH and equivalent resistance RTH respectively. So for this circuit we have to calculate the Thevenin equivalent voltage and Thevenin equivalent resistance. So let's first find out the value of VTH, right? So it is already open circuited, so from here we have to calculate the value of VTH. So this will be plus and this will be minus, so this is VTH. So VTH is nothing but the voltage across 4 ohm. So suppose this node is at potential V1, right? So we'll simply apply the nodal at this node. So mark the current in the outward direction, so it will be V1 minus 12 by 6, because this 12 volt source is opposing this current, plus minus 6 plus V1, so this is ground. V1 by 10 is equal to 0. So after taking LCM it will be 10 V1 minus 120 minus 360 plus 6 V1 is equal to 0. So it is equal to 16 V1 is equal to 0 and 480. So V1 value is coming as 480 by 16. So V1 value is coming as 30 volt. So we have calculated the value of V1. So VTH is the voltage across 4 ohm, so we can find out the value of VTH by the voltage division rule, right? So by voltage division rule. So VTH is equal to V1 into V1 into 4 by 10, right? Because VTH is the voltage across 4 ohm, so we have calculated the value of V1 as 30 volt into 4 by 10. So VTH value is coming as 12 volt. Next we have to find out the value of RTH. So in order to calculate the value of RTH, this current source will be replaced by open circuit and the voltage source will be replaced by short circuit. So our circuit will reduce to, so we have to calculate the value of RTH. So voltage source will be replaced by short circuit, and this is resistance. So current source is open circuited, and this was 4 ohm, right? So from here we have to find out the value of RTH. So this was 4 ohm, it was 6 ohm, right? Okay, so they are 6 ohm resistances. Now they both will be in series, so they both are in series, so it will be 12 ohm and 12 ohm in parallel with 4 ohm. So it will be 4 into 12 divided by 16, so it will be 3. So RTH value is coming as 3 ohm, right? For this question, option D is D is correct, right? So next question is the Thevenin equivalent circuit. The Thevenin equivalent voltage and the resistance across AB shown in the figure respectively are, okay? So for this circuit we have to calculate VTH. So first find the VTH, okay? For finding the VTH we have to remove the load. So our circuit will be like, so this is our current source 10 ampere. So this is 10 ampere current source in parallel with 2 ohm resistance, and so we have open circuited the 2 ohm resistance across which we will find VTH, right? So this will be plus minus VTH, this is 15 volt, right? So this 10 ampere current will come from here, and here no current will flow. So 10 ampere current is coming from here, and here no current will flow as it is open circuited. So this entire 10 ampere current will flow like this. So the voltage drop will occur like this, and the 10 ampere will flow like this. So the voltage across the 2 ohm resistance is 20 volt, right? So now we will apply the KVL in this loop in order to find out the value of VTH. So we'll start from here. So it is minus 20 volt plus VTH, and minus 15 is equal to 0. So the value of VTH is coming as 35 volt. Now next we have to find out the value of RTH. In order to calculate the value of RTH, current source will be replaced by open circuit and voltage source will be replaced by short circuit, and this 2 ohm resistance will be open circuited. So our circuit will reduce to, so in order to find out the value of RTH, so this current source will be open circuited. So here 2 ohm resistance is there, and we have to open this 2 ohm resistance, and this voltage source will be short circuited, right? So this is 2 ohm. From here we have to find out RTH. So RTH value is coming as 2 ohm. So for this question, option C is correct. So next question is, what are the source voltage and the source resistance respectively for the Thevenin equivalent circuit as seen from the terminals indicated in the circuit given below, okay? So basically for this circuit we have to find out the value of VTH and RTH. So first find the value of VTH. So suppose this is plus minus, so this is VTH. So let us assume the voltage at this node is V1 and the voltage at this node is V2. So high potential is connected with, so high potential minus low potential is equal to source value is VTH. So high potential is connected with V1 minus V2 is VTH. So if we'll find the value of V1 V2, we'll find the value of VTH. So V1 is nothing, so we can calculate the value of V1 and V2 by voltage division rule. So V1 value is total voltage into the resistance across which we have to find out the value of V1, which is 40 divided by sum of both, that is 40 plus 60, so it will be 100. So value of V1 is coming as 40 volt and the value of V2 is coming as total voltage into 60 ohm across which we have to find divided by 100, so it is coming as 60 volt. So VTH value is V1 minus V2, so which is simply 40 minus 60, so it will be minus 20 volt. But in the option it is given as 20, all the options are positive. It means they have considered this terminal as positive and this terminal as negative, so it hardly matter because in the question they haven't mentioned. So we'll consider this as positive, this as negative, but the value of VTH will be 20 volt only. Next we have to find out the value of RTH, right? So if we'll consider the mod of VTH, it will be 20 volt. Next we have to find out the value of RTH. So for finding the value of RTH, this voltage source will be replaced by short circuit. It means the overall circuit will be like this. So this is short circuited, so I have short circuited, and this is two resistances now, so they are open circuited, right? So it is like this. I have short circuited the voltage, so this is 40, this is 60 ohm, this is 40 ohm, and this is 60 ohm. So we have to find out the value of RTH. Suppose this is terminal A, this is terminal B, and suppose this is terminal C. So this will also be C because there is no voltage drop, so this will also be C and C, right? So now in between the node A and C, and A and C, these two resistances are connected. It means this 40 ohm and 60 ohm, they are in parallel. So it means 40 ohm is in parallel with 60 ohm, so its R equivalent will become 40 into 60 divided by 100, which is coming as 24 ohm. Similarly, this 40 and this 60, they are connected in parallel because it is connected between B and C. So it means our circuit will be like, so this is A, this is B, and this is 24, and this is also, so this is 24 ohm, this is also 24 ohm. So RTH is nothing but 48 ohm. So option B is correct, right? So for this question option B is correct. Let's see our next question. So next question is, what is the Thevenin resistance seen from the terminal A and B of the circuit shown in the above figure? Okay, so for this circuit we have to calculate the value of RTH from here, right? So for this, so for finding the value of RTH, current source will be replaced by open circuit and the voltage source will be replaced by short circuit. So our circuit will reduce to, so this will be our 8 ohm resistance, and this will be 3 ohm, and this is 5 ohm resistance, and this is 3 ohm. So this will be open circuit, and this is 4 ohm, this is 3 ohm resistance, this is 12 ohm, this is also 12 ohm, and this voltage source will be replaced by short circuit. So this is 4 ohm, this is 3 ohm, this is 12 ohm, this is 12 ohm, and this is A terminal, this is B. From here we have to calculate the value of RTH. So now these two are in series, right? So it will be 8 ohm, and 8 ohm in parallel with 8 ohm will give 4 ohm. So our circuit will be, so 8 ohm in parallel with 8 ohm will give us 4 ohm, which was in parallel with, this was 4 ohm, this was 3 ohm, so it is 3 ohm, and this is 4 ohm. Here it is 12 ohm, and this was also 12 ohm, and it was short circuited, right? So this was 12 ohm, this was also 12 ohm. So suppose it was terminal A and it was terminal B. So suppose this is C terminal, right? So this terminal will remain B, this will also be B, because there is no voltage drop. So now our circuit can be redrawn as, so suppose this is A and this is B. So in between A and B, so in between A and B, this 12 ohm is connected. So I'm drawing it like this. So in between A and B, this 12 ohm resistance is connected. Also in between A and B, this 4 ohm is connected. It means they both are connected in parallel, right? So this is 4 ohm, and let us assume this is C point. So in between A and C, 3 ohm resistance is connected, right? So this is 3 ohm resistance is connected. In between B and C, 4 ohm and 12 ohm resistance is connected. So this is 4 ohm and this is 12 ohm resistance is connected. Now these two are in parallel, so it can be solved to 4 into 12 divided by their sum, so it is coming as 3 ohm. Similarly these two will result 3 ohm. It means 3 ohm in series with 3 ohm, right, which is in parallel with 3 ohm. So this is terminal A, this is terminal B. So this is RTH is equal to R of AB is equal to 3 in parallel with 6, so which is coming as 3 into 6 by 9, so which is coming as, so RTH value is coming as 2 ohm. So for this question, option A is correct. So that's it for today's session. See you in the next lecture. Till then, bye guys.